Thermodynamics. Thermodynamics is a branch of physics concerned with heat and temperature and their relation to energy and work. It defines macroscopic variables such as internal energy, entropy, and pressure that partly describe a body of matter or radiation. Thermodynamics arose from the study of two distinct kinds of transfer of energy, as heat and as work, and the relation of those to the system's macroscopic variables of volume, pressure, and temperature. We can start the topic by talking about absolute zero. Absolute zero is found by using the pressure exerted upon a container of gas, as long as the molecules within the container have kinetic energy and are in motion, and by colliding with the walls of the container exert a force on it known as pressure. Well, this pressure decreases to zero at negative 273 degrees Celsius, and using what I explained above, can say that this is a place at which the molecules stop moving. This point is the stop of all motion and called absolute zero. We have to understand that negative 273 degrees Celsius is 0 degrees Kelvin, and both of them have a scale of 1 degree Celsius to 1 Kelvin. So, using this, we can find that 273 Kelvin is equal to 0 degrees Celsius. Defining the state of a gas. The ideal gas law, PV equals nRT, explains what must happen to an ideal gas when its pressure, volume, or temperature change. When you introduce change on one side of the equation, the other side will have to adjust in order to keep the equal sign. P stands for pressure, V for volume, N for the number of moles, R is the gas constant, and T is temperature. Okay, let's say that we somehow increase the temperature of a gas. Since the equation is PV equals nRT, increasing T means that the right side of the equation increases. Then, according to the ideal gas law, the product of the pressure and the volume must also increase in order to maintain the equal sign. Right. The equation PV equals nRT gets us to the PV diagrams, as they display what happens to either temperature, volume, or pressure when the other two quantities change. Defining these takes three laws, the gas laws. The first law is Boyles Law, second one is Charles' Law, and the third one is Lussac's Law. Boyles' Law is the relationship between pressure and volume at constant temperature. This is like a syringe on which a pressure P is applied and the volume decreases. The next one is Charles' Law, which is the relationship between volume and temperature at constant pressure. If using the same example of the syringe, if the gas inside is heated at the same pressure, the volume has to increase. And the third one, Lussac's law, is the relationship between pressure and temperature at constant volume. So basically, if the gas inside a container is heated, the pressure increases at constant volume. Right. Boyles' law. Boyles' law states that the absolute pressure of a fixed mass of an ideal gas at constant temperature is inversely proportional to its volume. PV equals to a constant. Charles' law. The volume is directly proportional to the absolute temperature at constant pressure. This is called isobaric, and V divided by T equals to the constant. Lussac's law. If a gas inside a container is heated, the pressure increases. P divided by T equals to B, a constant. Well, these laws can be used to easily understand PV equals nRT. PV is proportional to T, but the mass has to be taken into account and added to the equation, making it PV is proportional to MT. This can be made into an equation by adding a constant of proportionality, being different in different masses, but instead of using mass, we use moles N in the gas. Well, PV equal to nRT. A different way of stating the same formula would be PV divided by T equals to nR, or PV divided by T equals to a constant, or P1 V1 divided by T1 equals to P2 V2 divided by T2. Thank you for watching.